Writing net ionic equations. Balance the reaction if needed, assign oxidation numbers, write the oxidation and reduction half reactions, and then write the net ionic equation. So the first thing that we're going to do is see if we need to balance this reaction that we have here. So I look at this reaction and I say 1Ca, 1Ca, 1Pb, 1Pb, oh no, NO3s, we have 4 of them. And on this side, with my NO3 polyatomic, we have 2, which means I need to balance my NO3 polyatomics. Therefore, I'm going to need to put a 2 in front of this CaNO3 2, which will give me an overall 4 nitrate polyatomic, and as a result, I need to put a 2 in front of this Ca right there. And when I do that, I can look back at everything and say, hey, this thing is now balanced. So for a moment, I'm going to get rid of this 4 up here. The next thing that I need to do is assign oxidation numbers to all of the elements in my reaction. So I'm going to start with the Ca, and my Ca will be 0 because it is an element by itself. If I uncrisscross this 4 right here, it will tell me that the Pb will be plus 4. The NO3 I'm going to keep as a polyatomic because I know that NO3, just by looking at it, is not going to be involved in this redox reaction. But the NO3 by itself has an overall charge of -1. The Ca on the product side will have a charge of +2 because that is the only charge that Ca can be. Plus, I could look at this 2 right here and say, hey, I'm going to uncrisscross that. So Ca will be +2. Again, I'm going to treat the NO3 as a polyatomic and not look at the individual oxidation numbers for nitrogen and oxygen and just say, hey, this thing isn't changing. It's going to have an overall charge of -1. And then Pb by itself will have a charge of 0. The next thing that I'm going to do is figure out, obviously, what is changing charge. And we basically have already said this. We know that the Ca is going from 0 to +2, and the Pb is going from +4 to 0. So now the question is, well, what's being oxidized? And we know that oxidation is the loss of electrons. So if you said, hey, I think the calcium is undergoing oxidation, you are correct. So I'm going to make sure that I bring my coefficient with me, and I'm going to write 2Ca0, an arrow, 2Ca plus 2, plus the number of electrons lost. Now, I know that a single calcium atom, when it undergoes oxidation, will lose 2 electrons. When I have this coefficient of 2 in front, it's distributive. So that means I'm going to be losing a total of 4 electrons. Now let's look at the reduction half reaction. Pb does not have a coefficient in front of it, so I'm just going to write Pb plus 4. I'm going to gain some number of electrons and get Pb 0. So to go from +4 to 0, I need to gain 4 electrons. The next thing that I'm going to do is talk about, well, what is the spectator ion? And we've already really identified the spectator ion here, and we know that it is the polyatomic nitrate ion, NO3 -1, because as we go from reactants to products, we can see that the charge does not change. Therefore, it is a spectator ion, and it will not be written in our net ionic equation. So the next thing that I am going to do is to draw a stair step in between the reactant side and the product side. And now I'm going to cancel my electrons. So 4 electrons lost and 4 electrons gained. And then as a result, I'm going to write my overall balanced net ionic equation. So on the reactant side, I have 2Ca0 plus Pb plus 4 yields 2Ca plus 2 plus Pb0. And as a result, I have a balanced net ionic equation where the number of electrons lost equals the number of electrons gained, and I have not included my spectator ion.